Okay, here's an activity that looks at a function. Here's the graph of the function, and we're supposed to look at the graph of the derivative and the second derivative. So this is good practice thinking about what does a derivative actually mean. So the derivative of a function tells you what its slope is. So let's start with the simplest values first. Where is the slope of this function 0? So can you see that at 3 the function is 0? Negative 3. Whatever this point is, let's say negative 1.8, the slope is 0. Over here at something like 0.4, the function is 0. And at 2, the function is 0. So f prime of negative 3 is 0. The output is the slope. So what is the slope here is actually the height down here, right? I'm going to start with my zeros, okay? Now, can you see that my slope is negative here? How negative is it? Well, I don't know. Let's say that's about negative 1 right in there. So this is the steepest negative. Now, can you see I go from a slope of 0 down to a slope of negative 1. So you might say I'm coming down to that slope. Then my slope gets to be less of a negative. So here at negative 2.1, my slope isn't that steep a negative. But notice I'm going down on this whole interval. So my derivative is negative. Right about here, oh, I don't know what that value is. Maybe we'll say negative 0.45. That's let's say that's my steepest positive slope. Let's say that's a positive slope of about 2. That says my slope starts at 0 here, right? Then I get more positive. Maybe my slope's a half here and 1 here and going up. Maxes out there and then comes back down, right? Here my slope is, I don't know, maybe 1 or a half and comes down. Here on this interval, my slope is negative, perhaps most negative, about there. Oops. Most negative about 1.2 or something like that. So we'll say, yeah, I guess I have a most negative, maybe negative 2, somewhere around 1.2. Right? So can you see what's happening there? Now, going slightly out of order. So where is the function f of x increasing? Well, f of x is increasing clearly from that point up to that point. You can see this in the derivative even easier. It's where the derivative is positive, right? So it's on this interval, let's say negative 1.8 up to 0.4. Okay, that's where the derivative is positive. Okay, so now we're going to look at the second derivative. Now you can just sort of think of the same game with this. Hey, where's the slope 0 on this? Well, at this point, what is that? Let's say negative 2.5. The slope is 0. The slope of the slope. It's again 0 here. Let's say that's negative 0.6, something like that. And then it's again 0 here at, I don't know what we said this point was. Let's say 1.4. Okay? Okay, so then can you see the slope is negative here? It starts out at a higher negative and then goes to a lower negative. So it starts out at a negative number, a pretty negative number, and then goes up, right? Where's the slope steepest? Well, maybe somewhere around here. How steep? Maybe you say a little more than 2. So we've got to go up to 2, down to 0, right? Where's it most steeply downward? Well, looks like somewhere around here. So at this point, it's going to be most steeply negative. Let's say it's that negative. So it starts out slope of 0, slope of negative 0.5, negative 1, on down to something of almost a slope of negative 3. Back to here, right? And then my slope becomes positive. This is the slope of the derivative I'm talking about. So then it goes up, and I don't know what it does past that line. Let's say it does something like that. Okay, so this is the derivative of the derivative. Now, where is the function concave up? It's where the second derivative is positive. So I can look at this and I can say, this is something like negative 2.5 up to negative 0.6. And it's also on the interval 1.4 up to, we'll say 2, although it could go past 2. And I want you to notice that the second derivative tells us about the concavity of this picture. Okay? So we said from 2.5 to 0.6. Can you see that the graph is cupped upwards there? That's what it means to be concave up. That's what the second derivative tells us. The second derivative is negative from negative 0.6 to 1.4. Can you see that? That part of the graph is cupped downward, and so on. So the second derivative tells us something fundamental about the function itself. Okay, second part of this activity is working backward, okay? So can you see that I actually have here the derivative, and I say, what's the graph of f? Now, it turns out that height doesn't tell me anything about slope, so technically I can start wherever I want to on this picture. Let's say you could start at 0, although you could start at any point here, right? Well, I have a slope of 1, so for every 1 I go over, I'm supposed to go up 1. This is a constant slope of 1. That means it's a straight line. This is the graph that would give a derivative or a slope of 1, right? Opposite relationship of before. Now, all of a sudden here, I have a slope of negative 1, so I'm starting out going down, right? But by the time I get to here, I have a slope of negative 0.5. So somehow, pretty quickly, I round out. Here, I have a slope of 0. Now, again, you've got to think about this in reverse. If I was asking, hey, what's the derivative of this? Can you see this would be the place I'd have a horizontal tangent line, or my derivative would be 0. Now my slope starts to be slightly positive, more positive, all the way up to 1. So it's sort of the mirror image of what's happening back there. Here, my slope was 1. Now it's steeper. It was 1. The next instant, it's 2. This is actually a bit of a corner here. Notice the derivative doesn't exist right here. And so it's steep, but it's going down. By the time we get out to here, the slope is only to 1. And by the time I get to here, the slope is 0 or flat. So this function has this as its derivative. Now, where is the function f increasing? Well, again, that's actually pretty obvious. It's where the function's derivative is positive. So from negative 3 to negative 2, and from negative 1 all the way to 2. Negative 3 up to negative 2, and from negative 1 all the way up to 2. It's where the derivative is positive. You can look at the graph and, hey, it's going up from there all the way over to there, it's going up. Now, a second question, let's go back to this original derivative, and let's do what we did to begin with a straight line graph. Hey, what's the second derivative? What's the derivative of the derivative? Can you see that the slope of this derivative is clearly 0? So that's 0. What's the slope of this line? Well, it's a constant. It's 1. What's the slope of this line? Well, the constant is clearly negative 1. So when I take the derivative of the first derivative, I get the second derivative. Where is the function itself concave up? Where is it cupped upwards? Well, there's two ways to see that. I can see it pretty obviously here. It's from negative 2 to 0. Or you can look at the second derivative and say, hey, it's concave up when the second derivative is positive. That's from negative 2 to 2.